Hello guys, welcome back to the channel, and this is our next video and of linked list. So I have also released two linked list videos, and this is the continuation of this singly linked list video one. And if you are a beginner or a noob, you can check out my channel at named Sunish Srivastav, and you can check out data structure named linked list. And I'm yes adding and just producing the videos with all the questions that I can solve and that are majorly asked, which include some tricks or tips. So let's quickly move on to the to dos. So for the video single linked list video one, we have done till here, and for the next of the video, the task is to find the nth node from the end of the linked list, and the second is middle of the linked list to find the middle node of the linked list, to find the loop in the linked list, and the length to find the length of the loop in the linked list. The next is check if the list is palindrome and remove duplicate from the sorted linked list. So this is our task today for the video 2 of linked list, and let's quickly move to that. So uh, let's name that topic to linked list and quickly move to that. So finally, first is the nth node of the linked list, nth node from the end of the linked list. So that's our first question. So let's quickly solve that. Just make a linked list here. Um, let's just not make it here because we will be using for um, like everything. So 1, 2, 3, 4. So that's our first question majorly 5. Now let's say this is our linked list and we have to find the second node from the um, end of the linked list. So that will be 4. Now to solve this problem, basically I have already told that linked list is all about the playing with pointers, and if you know, like if you know some if you have solved earlier some types of questions related to linked list, then you will be easily be coming up with the solutions on how to solve that these types of problems. These are like the problems which require some sort of like useful information that should be available, and that comes through practice. So that's all about the linked list question, and you just have to maintain two pointer here. First is um, um like first is like you just say t temp pointer, and the next is reference pointer, let's say. So I am not able to write it clearly here, and okay, so let's just make it a ref pointer, and this is our head pointer. So now to solve this type of problem, you just have to uh, move directly the link and the input of n from the end of the linked list is n, and you just have to move the any one of the two special pointers to like n. So uh, just move the reference pointer till two places. So the reference pointer goes up here, and now you just have to move these temp pointer and the ref pointer one by one until the ref pointer reaches the end. So let's make it one more time clear, because here the situation goes more blurry and too much hodgepodge has been done. So let's just explain once more of that shit. So yes, um, let's just make it one more time. So 1, 2, 3, 4, and 5. So these are the pointers. This is the linked list, and this is the head pointer, and you have to place two storage pointers. And let's just change the color of the pointers. yes, we have these two pointers. One is temp pointer and another is ref pointer. So first is we have to do is assign temp and ref to head, and now you have given the user have given an input of the n, which is the nth node from the end of the linked list. Let's say it is 3 for my case. So n equals to 3, then you have to first move, change the color, and now you have to just move the ref pointer to n places from the starting. So 1 2 3. So now, um, yes, so basically the third pointer go ref pointer goes here, and you just have to move the ref pointer 3 times. 1 2 3. 1. Okay, I'm sorry, it's again close. Now we also already know the answer that the third pointer from the end is this node. So what we have, this is the answer basically. Just a second, guys. Sorry for that. Let's change that color to red, and we already know. Okay, we already know that this is our answer, which is the third position from the end. 1 2 and 3. So now you have to move the ref pointer to the nth place after it. So like it goes from 1 to 2 and 2 to 3 and 4. So the ref pointer goes to this position, and just a second, guys. So ref and temp is here. So yep. So back to this, guys. This is the ref pointer, and the ref pointer scales to this. You have moved n places 1 2 and 3, so the ref pointer comes here. Now move the ref and the temp pointer one by one. So the temp pointer will exactly be now pointing after the result after of moving, like when this goes 1 2 3 4 and 5. So the ref pointer is here, and now when you move it one by one, let's just zoom out something, and the ref pointer now goes here, and the temp pointer now goes here. Now the ref pointer goes here, and we have reached the end of the link. The temp pointer goes here. So this is the third position from the end of the linked list, and yes, we have finally got the answer. So this is the solution of our first problem, nth node from the end of the linked list, and this is the question that is like the basic one for the linked list. Now you just have to code that question. So let's just straight dive into the code. So nth node from the end of the linked list. Sorry. Okay, nth node from end. Okay, so let's just make a static class node and just like copy paste the whole thing. Okay, okay, we need this everything. I'm not writing it once again to save the time. Cancel. And what is this? Okay, now we have to remove these type of shit. Okay, so okay, uh, now I think yes, and this is clear. So you have to print the linked list. Now you have to find the nth node from the end. So let's just make another function. Now it takes another pointer node head and int element. So um, just like now you have to keep the node ref pointer and node temp pointer, which also points to head. So like if you have to find the nth element, you do not have to print the linked list, do not need to have while head is not equal to null. And so first of all, just iterate that um, okay. So guys, you have to just iterate the linked list uh, first of all, and then till the nth position. So basically, uh, this is the major solution. This is uh, so basically, guys, you just sorry for the delay. Gotten some notifications. Okay, so you just have to like we are at currently at the one position, and you have to just move till uh, element. So like you are in the first position here and you have to move three times, so one and this, so that is the third position of the linked list. So now just move that ref equals to ref dot next. And okay, so while ref dot next is not equal to null, you just have to do what, temp equals to temp dot next and ref equals to ref dot next. So why I have written that ref dot next is not equal to null, because then when the next element is pointing to null, that means we have reached the last element. Equals to null means that we have reached to the last element. Okay guys, so this is the find the nth node from the end. And uh, sorry for the delay. Yes, so you have to just print here temp dot element. No, okay, now let's just we have a linked list which like just find the first element, like just iterate it one more time, third element and the fourth element. So let's see what our output comes here. So nth node from the end. And so the first element from the end is fourth, correct. The third element from the last is second, correct. And the fourth element from the last is fourth. So it is yes, and this is the solution which requires two pointers here, and we have solved this problem. Basically, for the brute force solution, what you can do is that like if you do not want to play too much with pointers and you are good to go with the brute force solution, you just count the length of the linked list. First, you just count the length of the linked list, which is 5, and then you just subtract 5 minus 3. So 5 minus 3 plus 1. So that makes 2 plus 1 equals to 3. So your answer is 3 here. Okay, guys. So that is our solution. So that is finally this problem has been done. Okay. So now let's move on to the next problem quickly. And our next problem is uh, just we have done this nth node from the end. And the next problem for middle of the linked list. Okay guys, so you have to find the second problem is middle of the linked list. What you can do for the brute force solution is count the count the length of the linked list, and then like traverse to half of the middle, half traverse to like half of the length of the linked list. that makes two middle. But now you know that dealing with pointers is a very good case, and you just find the solution easily. So you have to do nothing here. Also, you have just keep reference to temp pointer again, and these are very small tips that is around the internet and that usually people follow in competitive programming questions. So that is a temp pointer, and another pointer is a reference pointer. Okay, so that goes easy. Okay, so another is a reference pointer. Now what you do here is that you move the temp pointer by 1 and the reference pointer by 2. So like with each step a temp increases by 1 and the reference pointer increases by 2 until the reference pointer reaches to the last of the linked list. Okay, so let's move the reference pointer first goes to here and then here. Like I'm not you have to do it simultaneously, but when I have to change the color, so I did it only one time. And the next point temp pointer then goes to here, and then the next temp pointer goes to here. So you have C in the middle of the linked list. The temp pointer now points to the middle of the linked list. Right guys, so this is the middle of the linked list, which is very easy to find. Now for there is one case, another case also, when there are even number of elements and there are two middles, then there will be like middle plus one. So how do you solve this problem is that you also keep the reference pointer and the temp pointer, and the temp pointer first scales by 1 and the temp pointer, like let's just map the temp pointer first. It goes from here, then it goes to here, then it goes to here, and then it goes to here. Okay guys, so our temp pointer goes to, it goes to here, it goes to here, sorry, first this goes to here and this goes to here, and next it comes here, the pointer goes to here, and the next it comes to here and the ref pointer goes here. So yes, the temp pointer again points to the middle of the linked list. So you just have to code this, and this is a solution to the next problem, middle of the linked list. So like this is the solution to the print the middle of the linked list, and you can just uh, code it easily. So let's just code it and move on to the next problem, middle of the linked list. Okay, so let's first of all, the copy paste is easily why why it is transferring the transfer references. I don't know. I just have to do some extra work for that. The code fragment you have pasted user classes that are not explicit classes that you want to import to a new file. No, I do not want. Now cancel, no, print linked list. I want that. So let's just want only that. Remove that. Okay, cancel. Okay, so you have again got to the linked list, and you have to just find the middle of the linked list. Now node head, and you just have to basically do not do anything, just keep up track to the node temp equals to head, and node reference pointer equals to head. Now while ref is not equal to null, or uh, like when ref goes to null, or like ref dot next, you just have to keep the point of the reference pointer here. So ref dot next want to work. um, okay, let's just code that. Let me think one more time. What is the middle of the linked list exactly? Because for this case, this will point here. The ref will goes to null. So before coding directly, you just can think of the solution and take time to what exactly can be done. So yes, have some time, and I'm thinking that uh, okay. Uh, can there be an AND condition? Okay. Yep. So what you have to do is ref equals to ref dot next, and yeah, just move the reference pointer by 2 times, and temp equals to temp dot next. Okay. Move it 1 time. Now you just have got the solution. Why is out not taking? Out. Okay. So out is um, theme dot element. So that is the middle of the linked list. Now just check whether our solution works or not. So yes, this is the middle of the linked list. 1, 2, 3, 4, and for even number of characters that should be 3. So yes, it works finally. For let's say 5 characters, let's just do that first. Odd number of characters, is it working or not? Oh, 5. Okay, dot next. Okay, this is working. So that's it, guys. This is the problem for the middle of the linked list, and like, when the reference pointer goes finally. So you there is for this problem there was I was thinking of the AND condition when because the ref pointer here is not equal to null, and sorry, and the ref dot next is also not equal to null. So what I did is that the ref pointer again goes here and the temp pointer goes here. So now for the next time it will not iterate because we have reached to the end of the linked list, and yes, finally middle of the linked list is completed. So now the next problem is to find the loop in a linked list. First we have to copy paste. I should make a generic class for this, I think, because that is taking of time. I will make a generic class that will automatically lifts the pointer to the created linked list, and I do not have to do same shit again. So yes, you just need this method also. Writing the same code again and again is a very bad idea. So for the next problem, and there's a like let me just clear it. And okay, so guys, next problem is middle of the linked list, sorry, loop in the linked list. So let's just find, let's just make a loop in the linked list, and so this is our problem for the root of the linked list. And now, so what you can do here is that um, for the looping you just have to take 2 pointers, again the ref pointer and the temp pointer and the head pointer as it is. Now you have to just find if there is a loop in the linked list or not. So basically there are 2 methods to do this. You can create like a hash table or something for that, or like what you can do is that um, like you can use a set or something. No, set won't work here, but like what you can do is you can create a string also. Let's just try this problem with the string. And mm, I don't know string will work or not, but array list of string, and you just keep the memory address of all the uh, like you just keep the memory address of all the linked nodes, and if that array list contains the um, if that array list contains basically any of the previously pointed nodes, then that means you have a loop found. So I think we can do that, and let's just try. So let's just do it first. I'm also thinking it right now, and that's a loop and linked list as a class. So just make it static void find loop and ll. So ll basically means the linked list. Do not get confused by what is ll now. So yep, find loop in ll. So what I'm gonna do is add a list of like integer. Let's just do that to integer or a string. No, string. So that will create that will have the addresses of all the linked lists. Okay, so while head is not equal to null, and if addresses dot contains head array list of, let's make it to node. Done, problem solved. Then you have to print loop found else else you can just keep a counter here. So let's keep that to boolean. Okay, sorry, why to keep a counter? Boolean looks cool. So boolean loop found equals to true and break. So, okay, so if loop found, then print loop found else no loop found. Okay, so guys, this is, let's check first of all that this is working fine. Loop in ll it I have not a dot next. Okay, that is the major missing. So yes, no loop found. So finally for this it's working, but let's just make this linked list to these type of linked list, and let's say whether we are able to find. So 1.2.3 is like this is something good. 3 and no 4, it is working good. Now the fifth node next points to 2. So head dot next dot next dot next dot next. I think I have written the same thing. Just now head dot next dot next dot next dot next. And that's the very head a dot next. So this makes to a loop and okay guys, I'm running into okay. Oh shit. A loop is found in the print linked list. Just stop. Oh shit, man. Okay, you do not have to call print linked list as it will. So That is running and not printing anything. Why? Uh, is it printing? Nothing is printed in the linked list. I think I've done something wrong. Head.next equals to head.next. That is correct. Why it is not uh, pointing to. Mm, let's just debug. So yes, no. Uh, and the major blunder I did here is that you have to all address dot add head. You have to do this also. I'm sorry. Loop found. Yep. So finally, guys, this is also working for us, and you have to just. I'm not doing this problem length of the loop in linked list. So you just can find you if you have find the loop, you can just keep the pointer to the loop here whenever the loop is fine, and you just count that like if you need this pseudocode, then if you have find the loop, so just keep a track to the pointer where the loop is found and just count again from here 1 2 3 4, and when again the pointer reaches to this, then break that loop. So yes, finally uh, this is done, loop and linked list. And then the next problem for us is that, what is that, check if the list is palindrome. So basically we can solve this problem by, let me just tell you one more algorithm, that is flavored cycle finding algorithm, which is used in finding the loop in the linked list. So 1 to 2 3 4 5. So what you can do here is that you can just keep the track of ref and the temp pointer again. I'm sorry, that is not finding any loop. Oh, that is okay. So you just keep track to the ref pointer and the temp pointer and just follow the same criteria as we did in the middle of the linked list. So move one pointer by 1 and other pointer by 2. So like this pointer now, temp pointer goes to this, and the next pointer goes to this, and again let me just do it synchronously, else I will get confused and you will also be confused. So okay, so like this is the temp pointer, ref pointer, sorry, and this is the temp pointer. I'm not changing the color, guys, it's taking too much time. So the ref pointer, temp pointer goes to this, and the ref pointer goes to this for the first iteration. What I can do here is that just I just have to keep change the location, so you will be able to distinguish between the ref pointer and the temp pointer. So this is basically the ref pointer above, and the one side, this below one is the temp pointer. So next it moves on to this ref pointer, and the temp pointer moves on to this. Now again this pointer, the next temp pointer moves to this, and the ref pointer moves to this. Now again the ref pointer goes to this, and the temp pointer goes to this. So you see that the temp and the ref pointer are at the same location now. So you have find the loop. Okay, so that is also the solution to find a loop in the linked list, and it is known as flavored cycle finding algorithm, and it's just like it is similar to finding of two animals. What I read is hare and tortoise, I think. So that's the shit. So yes, this is all about the linked list part. This is all about the linked list part, and this is the loop which we have find. So you just have to find the loop here, and for the like the problem that I have removed, you just, if you have find the looping pointer here, now you just keep that pointer save in a variable ptr, and now just uh, like move with another pointer called temp or ref, and now just move that temp pointer one by one until that reaches to pointer once again. So if you are moving with the temp pointer, then temp pointer 1, now increase the counter, 1, temp pointer moving 2, 3, and 4. So you have known the length of the uh, loop, which is equal to 4 here. So yes, this is the problem flavored cycle finding algorithm. So sorry for the writing, guys. And yes, this is flavored cycle finding algorithm that is written very bad. Let me just write it once again. Flavored cycle finding algorithm. So this is our majorly algorithm that I was talking about, and so remove that and the dirty part. Okay, and this was our algorithm. So I think that's an easy problem, and you just have to play with the pointers. I think you have already know what exactly is these algorithms do and what you have to do basically in the problems of linked list. So singly linked list is basically all about this ref pointer, temp pointer, and head pointer. And if you are very good to go with these pointers, then there is no issue. So the next problem we are going to cover here is that we have to check if the list is palindrome or not. So for the palindrome part, let's just quickly code that palindrome ll. So there are a variety of methods that goes with the palindrome of linked list. You can read it on Geeks or some other site. That's and I'm not going to cover all that because doing too much of stuff is also very harmful and cancel, and it is pointing to the references. I don't know why. So okay. So next is okay. So middle of the linked list, I have copied the whole linked list again, and you have to check whether the linked list is palindrome or not. So for the palindrome, what you can do is like create 1 2 1. This is palindrome. So for the palindrome part, like 1 3 3 1, this linked list is a palindrome. So to check that, you can like there are methods to use stack. So what you do here is that you just traverse the linked list and add. Okay. Uh, what you do here is that you just traverse the linked list and add all the elements to the linked list. 1 3 3 1. Now, so now again traverse the linked list and pop the elements. So matches, again three matches, three mm, three matches, and one matches. So when the bucket becomes empty and you are also pointing to the null, that means the linked list is palindrome. But what is the problem here is that you use on extra auxiliary space. Um, so to solve this problem, basically what you can do here is that 1 3 3 1. To solve this, what I think is that you can use the string builder class. I'm not wrong if let just try something called a string builder. and for this problem no string builder and pass 1331 and just print string builder dot reverse. Let's say what it prints. If it reverses the exact same string, that I think you are good to go. Yes, so you just not have to do anything, and you just also solve the problem of using extra auxiliary o in space. I'm not pretty much confident what auxiliary space string builder use, but on reading on the Stack Overflow, uh, I I can say that string uses O1 auxiliary space because it's only one instance of the string. So string builder class O1 auxiliary space, and you can solve this problem by this. So what we can do here is that let's just um, find palindrome or not, and just keep a point to the head of the linked list, and while head is not equal to null, just keep a string builder class. Okay, 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 string builder. Okay, so string builder dot add append string builder dot append string builder dot append head dot element, sorry, and you just head equals to head dot next. Now what you have to do next is that you have to just string s equals to string builder dot reverse or to string. Okay, solve the problem, and then you have to check that string builder dot to string not equals, ignore case, not equals s, so you can just find that whether the string is palindrome or not. Oh, I think that problem is also solved. True. So yes, the problem is solved using the string builder class, and we have also then from this that list is palindrome or not. So the next problem that we are gonna solve is that remove duplicates from the sorted linked list. So removing duplicates, there can be two lists, that is sorted and unsorted. So what you can do for the unsorted is that for the unsorted linked list, just first of all sort the linked list using any sort type of sort. So I will also be covering the sortings in the meanwhile after these videos, that I will also be touching the algorithm part and will be moving synchronously with the data structures and algorithm. So basically 2 videos are left for the singly linked list, and then we'll move to circular linked list. So we have majorly done 5 5 10 10 5 or 6 prop 5 for the 20. So 20 to 21 problems of linked list are being covered on these videos, and yes, and that's a great scale for the singly linked list. I think we have done a more problem than anything. Yep. So uh, just let's remove duplicates, and for the sort, and so I was telling that for the unsorted linked list, first just sort the linked list 12 11 13 and then 12. So for this, now just first of all sort the linked list 11 12 12 13. So what we can do here is that you can also do just go on like in an array of integers and add all the integers arrays, and then apply arrays.sort function of the util class of Java, and you can easily sort these array list in descending and ascending order, and then create another linked list and just remove the duplicates. What is that? One thing we can do is to remove the like for the removing the duplicates. What you can do here is that you can use the set of elements, integer elements, and just add all the integer elements and make a linked list of that. You are good to go. I think I should use this only for this problem solving. So let's just copy that first, and okay. I think what why we should, like, you just have to create a linked list which is contain removing that what like, and let me just, there are too much thought process in the mind. One, three. What people do generally is that they iterate from the head of the linked list and compare the next pointer every time. And if that is same, like this is same here, so these point to this now. No need of these things. Why should we do that? Let's just use set of integers and form a linked list. Nothing else. So when set is available, why do we do that? So remove, let's just make a function duplicate, and now what you are gonna do here is that you just keep a pointer. Okay, what people generally do is that I told you that they loop from one pointer to the next, and if the next pointer is similar, if the next element is similar to the previous element, then they do that to next. Let's just do that first. So while head is not equal to null, and you just have to temp equals to head. So if temp dot element equals to head. Okay, okay, head dot element. What I did here is that, like, so temp dot next equals to head dot next. I think that sounds cool. So like just let's just run the pseudo code here first. Temp and head. If that element is not okay, so when temp is not equal to next, then temp plus one and head plus one. Now temp is equals to element, so temp dot next equals to head dot next. Okay, I think that would be working. Temp equals to temp dot next and head equals to head dot next. You can also do it by I have not printed this out. 1 to 1 and it will, like, I have not printed that linked list. So you just have to create href. Okay guys, so just move on quickly. Oh, you just have not to print linked list. Yes, finally 1 to 1 and null. Oh my god, it is not working. Nice to hear that. Temp dot next equals to head dot next, and like when it is not equal to temp dot element equals temp dot next equals to head dot next. Where we have gone wrong. So let me just check. Temp is equals to head equals to head dot next. 1 and 2, head is not equal to null. Temp dot element is equals to head dot element. No, then temp equals to temp. Okay. So I think, yeah, this is not duplicate elements. It is working fine. I'm sorry for that. Let's just change the linked list to 112 and see what are the effects. The code is written fine. I am confusing. Yeah, done. So yes, finally we did covered all the problems here, and all the 5 problems, 6 problems which I mentioned to find the loop length, I have also told you the code about pseudocode about how to implement that, and you just need like a flared cycle finding algorithm is also a very fast algorithm, and you can just go with it. So finally, these two videos are done here, and don't forget to share it, guys. It's a very good problems that I'm covering, and I'm also learning. So like learning should have a cripple factor, and that should spread as like water. So thank you, guys, thank you for watching, and the next video for like code forces problem is also coming up soon, because I have not uploaded it today, and the next problem is for uh, these questions. Yep, next video should be about that, and the next is that. Now we'll be moving to, like, once this is completed, now we'll be moving to circular linked list. I will be finding the problem that I need to cover, and okay, so as this is completed, I will find the next problems which I need to cover in circular linked list first of all, and then we will be moving to doubly linked list. I think they do not have more than 10 problems, and then we'll moving to introduction of skip list. So that's all about the linked list, and the next data structures, like for the next data structure to be covered is stack and queues. So that is basically our flow for the week. I think I might be covering it day by day, every day. I might be covering. So yes, stack and queues, and then we will be moving towards hashing, and then hashing keep, mm, like binary search trees, BSTs, like trees, and then the more obvious and the very last thing. So these two and three things are the majority that has been asked and has to be done like seriously with the cream layer. So yep, thought process and thought for the days. So thank you, guys, thank you for watching again, and bye bye, take care.